Hi everyone. In this video, I would like to discuss briefly some basic concepts of statistics and also introduce you to descriptive statistics. Basically, this video is also a response to your questions and comments that you have posted on our discussion forum. Let's get started. So what is statistics? How do we define statistics? And what kind of statistics are we going to discuss this whole semester? If you still remember, in our first Zoom meeting, I mentioned that the statistics that we are going to learn, that we are going to discuss together in this semester, will not be the pure statistics in terms of a branch of mathematics. But instead, we are going to discuss statistics as a range of techniques and procedures for quantitative research. Correct. Okay, so we define statistics here for us in our context as a range of techniques and procedures for analyzing quantitative data, for interpreting the data, for displaying the data, and making decisions based on data. Therefore, when we talk about statistics, we will also talk about quantitative research. So I do hope you will not forget the concepts that you have learned as well in quantitative research course. Okay, so now that we have the same perspective, that statistics will be discussed in terms of main data analysis technique for quantitative research, let's proceed with some basic concepts that you have to understand in order to be able to use statistics later for your quantitative research. There are basically two important terms to start with. And these two important terms are related to quantitative research concepts as well. Okay, what are these terms? We have first the term parameter, and then another term is statistics, yeah? But the term statistics here is different from the statistics that we have defined earlier in this video lesson, yeah? If you read this book, our main reference, of course you have read this because your previous assignments were related to this book. Your previous reading assignments were from this book, right? So you also find the term parameter and statistics in chapter 2, the basic concepts in statistics, yeah? Okay, when we talk about parameter and statistics, we talk about it in terms of two basic concepts we find in quantitative research, namely population and sample. Okay, I know that you are still starting your quantitative research class as well, so you might not learned about this yet. You might not understand about these two concepts yet, yeah? Well, to explain about these two terms briefly in a simpler way, later on, you will learn about these two terms further in your quantitative research course. Okay, when we talk about population and when we talk about sample in quantitative research, we talk about the group of our research interest, who we want to investigate. That's population, yeah? From which or from whom you would like to collect your data. That's your population. Population is the whole group. Sometimes the whole group is very big. Say, for example, in terms of a country or a nation, the population is Indonesia as a country, for example. And of course, you will have a lot of people or a lot of data sources in this particular population. So that's why sometimes it is not manageable to do. It's not feasible to investigate. How to investigate? By selecting sample. Sample here is a representative of population. So population is a big group of your research interest, and then sample is the smaller group, a part of this big group, which is representative. Okay? You will learn further later in your quantitative research course. Okay, so what is the connection between these two research concepts and these two basic statistical concepts? Okay, as you know that statistics is a procedure to analyze data from research, right? So you can guess that these two terms have something to do with data analysis for these two other terms. Okay, so you can see here, you can read here, the definition of a parameter is a characteristic which is usually numerical quantity or in the form of numbers measuring some aspect of a population of scores. So if you use formula or calculation to measure some aspects of the population, you call it a parameter. Yeah. For example, you calculate mean score or you calculate average score for a population. That average score is called a parameter. But when you calculate particular measurement for sample, we call it a statistic. Okay, so parameter and statistic both are numerical quantities measuring some aspects, but taken from different groups. Parameter is for population, statistic is for sample. Okay, so please remember these two terms because they will be related to other concepts that we are going to discuss later, yeah? Okay, when we talk about the types of statistics, we can categorize these types into two indicators. The first one is based on the function, yeah, on the use, and then the second one is based on the data distribution. Based on the functions, we have first what we call descriptive statistics, which are going to be discussed further later in this video as well. And then the second one is inferential statistics. From the name, you can actually guess the function of these different types of statistics. Descriptive statistics, from the name descriptive, the function is to describe. And then inferential statistics, the function is to infer. Yeah, okay. And then based on the distribution of data, we will discuss about data distribution later as well in this course. There are two types of statistics. The first one is what we call parametric statistics. And the second one is what we call non-parametric statistics. Yeah, if you still remember in the previous slide when we talked about parameter versus statistic, yeah, parameter is related to population, right? So parametric statistics, you can guess that it might has something to do with the data distribution and population, or the data distribution in the population, yeah. And the non-parametric means, well, it's not the parametric one, right? Okay, yeah, we'll see later the detailed explanation on these two types, yeah? Okay, but first of all, please remember, based on the functions, you have statistics that we use to describe and the statistics that we use to infer. And then based on the distribution of the data, we have parametric statistics and non-parametric statistics. Okay, descriptive statistics. In a simpler way, we can define it as statistics that we use to describe, yeah? But what does it mean to describe? To describe means to summarize, to organize, and to make sense of a set of scores, or sometimes observations, yeah? But this is referring to quantitative observations, not qualitative observations, yeah? Okay, the examples of descriptive statistics will be very familiar already. We call it central tendency. There are three statistics there: mean, or the average score or average value; median, or the mid value, value in the middle, yeah. And then mode. Mode means the most frequent value or the most frequent score. Yeah, okay, so you have mean, median, and mode for descriptive statistics. So we call the three of them central tendency. Okay, other types of descriptive statistics include percentage and frequency. Percentage and frequency. The next one, inferential statistics. Okay, the function is to infer, but what does it mean by the word infer? Infer means to conclude or generalize observation made with samples to the larger population. What does it mean? Okay, so going back to the explanation earlier, when we do a research, we have a target group to investigate. This target group, which includes everyone and anything or everything that we are interested in, this whole big group is called population. Yeah, but since it might be too big for us to manage or to investigate easily or feasibly, then we take representative of the members from this bigger group. The representative is called sample. Yeah. So what we do when we use inferential statistics is that we try to make or to draw a conclusion about our investigation result for the population from the sample. Yeah, so we can conclude or we can draw a conclusion about a bigger group from data that we calculate with the smaller groups of representative. Okay, so that's why if you remember something about quick count or survey, okay, quick count or survey is not done with the whole population. They are done with samples, yeah? But the results calculated from these samples are supposed to represent the whole group of population, yeah? Okay. We also use inferential statistics to estimate and to test our hypothesis. Okay, again, this one is related to quantitative research. When you learn in your quantitative research course later on, you will discuss about hypothesis as well, yeah? But in a simpler word, hypothesis is our temporary scientific assumption. Yeah. Okay. Examples of inferential statistics include some tests. T-test is very popular, and then followed by ANOVA and then MANOVA. Yeah. I'm not sure if you have experienced reading journal articles already or research reports already, but if you happen to read quantitative research reports, you might encounter or you might find or you might see the names of these tests as the statistical procedures used by the researchers to analyze their data, their quantitative data. Yeah, we're going to learn about this further later after the midterm. Okay, so that's about descriptive statistics and inferential statistics. Yeah, please remember that the difference is on the functions. Descriptive statistics will be the basic one, so you have to learn about descriptive statistics first, and then afterwards you can proceed to inferential statistics, because the statistics that belong to inferential statistics also include some of the descriptive statistics. So that's why if you do not understand about descriptive statistics, it might be difficult for you to go on to inferential statistics. Yeah. Okay. Oh, sounds complicated already, right? A lot of people think that they hate statistics, but unfortunately, in our daily life, and also later on for your research, we do need statistics to some extent. Yeah. Even when you do a qualitative research, sometimes, although not all the time, sometimes you might still have to use a little bit of statistics, yeah? But later you will learn that in your qualitative research course in the next semester, not now, not yet. Yeah? Okay, parametric and non-parametric statistics. These two types are related to what we call data or data distribution. Okay, wow, this looks very much mathematical, right? With the curve. Okay, seems like it's quite difficult, but later you will, after you learn some concepts further, you will understand what each of these curves mean. Yeah, you will understand what each of these curves refers to. Okay, but first of all, what you have to remember is that when we talk about data distribution, we talk about three types of distribution. In the middle, you have something with a bell shape like this. We call it normal distribution. And then when you have normal distribution, you can use parametric statistics. Yeah. And then the other two types is what we call the skewed distribution. If you take a look at the shape, It's not really bell-shaped, it's not symmetrical. It has a tendency to skew to other directions, not peaking at the middle like this, right? Not peaking in the middle like this. Okay. When you have skewed distribution, you will have to use non-parametric statistics, but we will discuss about this later in the next meetings, yeah? Okay, what you have to understand now is that, okay, you have 3 types, and then these types are related to parametric and non-parametric statistics later, yeah? Okay, let's go on. Yeah, data distribution, just some fun meme to refresh your mind a little bit. Okay, parametric statistics are statistics where the population is assumed to fit any parameterized distribution. So just like what I said previously, when you have normal distribution, when your data follow a specific bell-shaped curve, yeah, when your mean, median, mode are in the same place or same spot in the middle, then you have a normal distribution, and then you use parametric statistics. But when your data distribution is skewed either positively or negatively, it's not symmetric, it's not symmetrical like that, then you can use the distribution-free statistics or the non-parametric statistics, yeah? Okay, you can also read further explanations here in this book. Okay, yeah. Now, what is the next important concept that we have to know? The next important concept is what we call the scales of measurements or the number identities. This is very important. Why? Because you know that our data for quantitative research, which are going to be analyzed by using statistics, are in the forms of numbers. The data are numerical, the data are numbers, but can we say that all numbers have the same meaning or the same identities? So you might have percentage, you might have frequency, you might have decimal points, right? And then you might have different numerical scales. So these numbers, these numerical data might have different identities. Just like you as a person, you have your own identity, which is different from your friend's identity, right? So are these numbers. So are these numerical data. Okay, so that's why you need to know the identities of the numbers in order to be able to choose which types of statistics you can use. Yeah, okay. So there are 4 scales of measurement. The first one is what we call nominal scale. Okay, this might be tricky to understand for us Indonesians. In Bahasa Indonesia, when we say the word nominal, we always associate this word to money, right? Okay, nominal uang, which means jumlah uangnya, right? Okay, but that is not the same here. It's not the same at all, yeah? Okay, what we call nominal scale here, the numbers which belong to a nominal scale are numbers that identify something or someone. They are in nature not really a true number, but they are in the forms of categories. And these categories are converted, dikonversi atau diubah into numbers, because statistics need numbers. You cannot have words or categories and then put words or categories into formula, right? You have to have the numbers or numerical data. So that's why we change some categories into assigned numbers. And when you have that kind of number, you have a nominal scale. Yeah. For example, the easiest example will be gender. Yeah. As you know that there are categories of gender. Yeah. The classic categories will be the binary gender group, male and female, or female and male, right? But depending on the context or situation, you may also have another non-binary gender group. So you might have female, male, and yeah, the ones who don't want to belong to either male or female, the non-cisgender group. Okay, so you might have like 3 categories, right? Okay, but you cannot really input these categories into statistical formula. You have to change them into numbers. So for example, you have female, male, and then the non-binary. So you have 1 for female, 2 for male, 3 for the non-binary, for example. Yeah, there is no exact rule to say that, okay, this is 1, this is 2, this is 3, but that will be the decision of the researcher or the decisions of the statisticians. Yeah. Okay. Marital status also. Yeah. You have single, married, divorced, for example. At least 3 groups. Single, maybe 0, and then married 1, divorced 2, for example, or just assign the numbers in randomly. Yeah, but the most important thing is that you know, as the researcher yourself, what 0, 1, or 2 refers to, what they identify. Yeah. Okay, and then the second one is what we call the ordinal scale. Ordinal scale is the scale that conveys order. Okay, another name for ordinal scale is ranked. Yeah, ranked scale. Okay, when you have a rank or when you have an order, it means that the value of something is greater or less than another value. Yeah, okay. And then interval scale. Interval scale is a scale where the values have no true zero and the distance between each value is equal. Interval. Interval itu biasa sekian sampai sekian, sekian sampai sekian, right? But they don't have true zero. Yeah. For example, temperature and IQ scale. Okay. But means we have 0 degree, right? 0 derajat itu ada kan? Yeah. But when you say 0 derajat, it doesn't mean that there is nothing, that it's totally nil, nothing, but it's just 0. 0 means it's you have 1, 2, 3, the numbers above, and you also have the minus degree, right? Okay, so 0 here is not true 0. It's not really empty or nothing. Yeah. Also IQ scale. No one really has like an IQ of 0, right? It has to start at something. Okay. TOEFL score as well. When you have TOEFL score does not have true 0. Yeah. Okay. Ratio scale. Ratio scale has a true 0 score and the scores are distributed in equal units. Okay, later on, you will learn that interval and ratio scale, they use the same types of statistics. Yeah, okay, so that's why later when I introduce you to software like SPSS, when talking about scales of measurement, we have only 3. Yeah, why? Because interval and ratio, they use the same statistics. And then you have another type of statistics for nominal. You have another type of statistics for ordinal. Yeah, okay. Yeah, the examples or the instances of ratio scale will be when you have measurement of length, height, weight, and time. Okay, as a researcher in the field of English language teaching, which of the scales of measurement are we going to use? Well, we might basically use all of them. Yeah, it depends on your research questions and on your instruments. Yeah, okay. But when you have something like test, when you use speaking test or writing test, reading test, then most likely you will have scores, right? And then the scores can be interval scores, or when you have true zero. What does it mean by true zero? When you have like 0 for not answering anything correctly. Yeah, well, you can say that it belongs to these two, yeah, interval and ratio scale. Yeah, okay, but if you are dealing with something like gender, then it is nominal scale. Yeah, okay. So you can read further from this book, and you can try to find also some more concrete examples of each type of scales of measurement, yeah, in order for you to be able to understand clearly about this particular concept. Okay, so those are the basic concepts that you need to know. Let's continue then. Okay, in this book, you have quite a lot of basic concepts, yeah, but of course, not all should be explained or should be discussed this time around for the introduction. Yeah, some of the other concepts here, we will use them for later meetings, yeah, for the next topics as well. Okay. Yeah, something like sampling. Okay, you will actually discuss this later in your quantitative research class, but we will use the concepts with practical statistical tests. Yeah. Okay, so now let's move on to descriptive statistics. So last week, you already did an assignment related to central tendency, right? Okay, central tendency included basically 3 statistics, namely mean score, median, and mode. Yeah, basic statistics. I believe that you have learned this at school before. Yeah, okay. Maybe in Bahasa Indonesia, not in English. This time you have to use some English terms. Yeah, okay, but actually just the same concepts. Yeah, just different language. Okay, but here we have another one, range. Yeah, well, range is a little bit in between. Some statistical experts put range together with mean, median, and mode. So in the central tendency, but some other experts put range together with the next types of descriptive statistics, namely variance and standard deviation, which are under measures of spread or measures of dispersion. Yeah. Okay, so let's just discuss this very briefly, talk about this very briefly. Mean, everyone knows, mean refers to the average score. Yeah. How to get the mean? Okay, in your previous assignment, you were asked to find the formula. If there is a formula, I will check later from your calculation whether you get the correct formula or not. Yeah, and then median is the mid value. Okay, what do we need to consider about median? Okay, different from the calculation for mean. To calculate median, you need to put all the values into order. You have to sort the values, yeah? Okay, from the smallest one to the biggest value, right? Okay, and then what you need to do is you have to locate or to identify the middle value, yeah? Be careful because you will have different way to calculate median or to identify or to find median when you have different size of your sample or data set. Yeah, when you have the odd number and when you have the even number. Yang jumlahnya ganjil dan yang jumlahnya genap bisa berbeda, ya. Oke, and then mode. Mode ini dicari yang paling sering muncul, ya. So the value that appears the most. And then be careful, you might have more than one mode in one data set. Yeah. Okay, now let's move on to the next type of descriptive statistics. Measures of spread. Yeah, but before we go on with this, let's go back here. Okay, to see the range. Okay, range is the difference between the lowest and the highest value in your data set. Nilai paling rendah dan paling tinggi, jarak antara nilai paling rendah dan paling tinggi di dalam data set yang kalian punya. Ya. Oke, nilai yang paling rendah itu kita sebut dengan istilah minimum score. Kemudian nilai yang paling tinggi itu kita sebut dengan istilah maximum score. Ya. Oke, apa yang harus kita lakukan? You subtract the lowest value from the highest, the minimum score from the maximum score. Oke, jadi misalnya maximumnya adalah 8, and then you have 2 as the minimum score. So 8 minus 2 equals 6. All right, so the range of your data set is 6. Okay, so when you talk about mean, median, and mode, you talk about values somewhere in the middle of your data set. Yes, somewhere in the middle of the data set. So that's why we call it central tendency, because it has the tendency to be located in the central part or in the middle. Yeah. Range talks about something else. It's about distance. Yeah. So that's why, okay, some experts also categorize range into other types of statistics or other types of descriptive statistics which deal with distance, namely the measures of spread or the measures of dispersion. Yeah. Okay, we have 2, 3 if you include range. Yeah. Okay, but range will be something in between central tendency and measures of spread. And when we specifically talk about measure of spread, we have variance and standard deviation. Variance dan simpangan baku in bahasa Indonesia. Ya, okay. Variance, what is a variance? Variance is the mean of the squared deviation scores. Okay, deviation. Okay, later you will read from the additional handout. Deviation here means the distance between an individual score and the mean score. Jarak antara nilai individu yang ada di dalam sebuah dataset dengan nilai rata-ratanya. Yeah. Okay, so in order to be able to calculate variance and standard deviation, you have to calculate the mean score first. Harus menghitung mean score-nya dulu. Yeah. Okay, in the additional handout later, you will see the example of the step-by-step calculation. Bagaimana menghitungnya dengan rumus dan step by step. Yeah. Okay. All right. So why do we have to learn about variance and standard deviation? Because we want to know how far relatively the deviation or the distance between individual scores and the mean scores. Are the individual scores in that particular data set close to the mean or far away from the mean? Nilai-nilai individu yang ada di dalam satu dataset, apakah nilainya ini berdekatan dengan nilai rata-ratanya, ataukah jauh dari nilai rata-ratanya? Ya, oke. Sehingga when we calculate variance and standard deviation, when your variance and standard deviation values are smaller, that means that your individual scores are closer to the mean scores. Yeah, they're not that much far from the mean scores. Tidak terlalu jauh dari mean score-nya. Yeah. Okay. So you have a more homogeneous data. Datanya lebih homogen. Yeah. But when your variance and standard deviation values are big, that means that you have a gap, a larger gap between your individual scores and your mean scores. That means you have a tendency of more heterogeneous dataset. Datasetnya lebih heterogen. Yeah. Okay, that's variance and standard deviation. Yeah. Later you will have to do an assignment related to variance and standard deviation. Yeah, with some formula. And then if you notice, the formula for variance and standard deviation will be different if your data is from population, if your data are taken from population, or taken from sampel. Ya. Formulanya atau rumusnya akan berbeda jika kalian mengerjakan data yang diperoleh dari populasi atau data yang diperoleh dari sampel. Ya. Okay. Yeah. So here you have the formula, ada rumusnya. Kalau dilihat di sini di dalam rumusnya ada min-nya kan. Kemudian ada X, di sini X adalah nilai individu ya. Jadi nilai-nilai yang ada di dalam data setnya itu adalah yang kita sebut dengan nilai individu ya. Kemudian ada min-nya. Sehingga kalau mau menghitung variance and standard deviation, the first step is to calculate the mean score. Langkah pertama harus mencari dulu nilai rata-rata. Okay, that's variance and standard deviation. Ya. Oke, apa sih bedanya tadi variance dan standard deviation? Standard deviation itu adalah akar dari variance. Sehingga kalau mau mencari standard deviation harus menghitung dulu variance-nya. Ya. Oke, kenapa kok Ini kuadrat, yang ini akar. Oke, nanti akan kita bahas ketika kalian sudah selesai mengerjakan assignment measures of spread-nya, ya. So I will discuss that in the feedback for this assignment, ya. Okay, so you will have another assignment related to measures of spread. You have done already the assignment related to central tendency, yeah. So after you do these two assignments, later we will have a feedback session, yeah, in which we discuss further why do we need to know how to calculate central tendency and how to calculate measure of spread in our real life, in your real life as students of the teacher training faculty, which means that you are now pre-service teachers, right? You are now in training to be teachers. Why do you need to know this while you are going to teach a language, namely English? Yeah, why do you need this one? And in our daily life, why do we need to know this? Yeah, you will have to find the answer later, and then we will discuss it later. Okay, so that's the end of the basic introduction to the concepts of statistics, including descriptive statistics, which you are dealing with these 2 weeks. Yeah. Next step, please write down one comment summarizing what you have learned from this video down there in the comment section, and then continue with your assignment related to measures of spread.